Continuing on in section 10.6, I have example 4, finding the measures of angles. What is the measure of each angle in the triangle on the bottom of page 647? So angle B, we know. B is our 90-degree angle. But here we have two side lengths, but no other angle measures. So in order to figure them out, we pick one of our angles. Doesn't matter which one. I'm going to pick A here first. And from A, I determine what my two sides are. So from A, my 12 is my adjacent. It's part of my angle. It's right next to and touching my angle here. It's my adjacent side. My 24 is my hypotenuse. Okay, it's the other part of my angle. It's opposite of my 90 degrees. It's my slanted side, and it's my longest side. So right now I have an A and an H. And if I look at SO, CA, TOA, A and H means cosine. So I'm going to take cosine of angle A, and A over H is 12 over 24. So CA means cosine equals A over H. Here, to move my cosine to the other side, we have to do the inverse, just like we have with adding and subtracting, multiplying, dividing, squaring and square roots, for example. We do the inverse. And this is actually, if you press second cosine, we get a key that looks like that. And we're going to do it to both sides. Okay, so A equals inverse cosine of 12 over 24. And when I do that, I get 60 degrees. Here's how I remember. So sine, just regular sine on my calculator, deals with sides. And if I want something for my angles, I use the one with the -1 there. Because that's up there like a degree sign. So that's how I remember when to use which one. Sine, for example, key is for my sides. And for my angles, I use the one that has a little -1 up there. So right now, I know that angle A is 60 degrees. And there's a couple different ways we can find angle C. We can use the fact that triangle angles add up to 180 degrees. And we can subtract there from 180 to get to 30. Or I can do the same process again, and that's what I'm going to do just to practice here. So if I pick angle C first of all, I have to figure out my 12 and my 24 based off C. So for C, my 12 is opposite. And again, our hypotenuse is always our hypotenuse. So here, if I'm looking for O and H, so is what I'm looking. And that means sine equals opposite over hypotenuse. So sine of angle C equals my opposite, 12, over my hypotenuse, 24. And just like we did with cosine, and we used our inverse key there, we're going to do the same here. So sine, with the little -1 there, it's not an exponent, it's just to show that it's the inverse. And we do that to both sides. So I get C equals inverse sine of 12 over 24. And again, we get there by pressing second sine, and then 12 over 24, and here we get 30 degrees as well. So again, once we find one of our angles, we can either do the same with our other angle in that we use our two sides and our inverse key, or we know that triangles add up to 180 degrees. So either way there. Now feel free to pause here and give this a try. In a right triangle, the side opposite angle A is 8 millimeters, and our hypotenuse is 12 millimeters long. What is the measure of angle A? So for angle A here, it already told us that 8 is opposite, but if we weren't sure, our picture would look something kind of like this. It also told us 12 is our hypotenuse, but that's opposite of our right angle, so we can see it from a picture here as well. If I have an O and an H, I'm looking at my SO, CA, TOA, and I want SO. So sine of my angle A equals opposite over hypotenuse. My opposite is 8. My hypotenuse is 12. Now, to get sine on the other side, I take the inverse, and those cancel. Okay, when I take the inverse of something, it disappears. So I have sine -1 of 8 over 12. Inverse sine of 8 over 12. And again, that's because inverses undo each other. So inverse sine undoes sine, and it helps us find our angle. When we type this in, we get approximately 41.8 degrees. So angle A is 41.8 degrees. Angle C I have marked as my 90 degrees. Now, just for extra practice, let's try and find angle B. So from angle B, 8 is going to be adjacent, and H is always the same, whether we're going from A or from B. Our hypotenuse is always the same. So here, because I have A and H, I'm going to use ca. So cosine of B equals A over H. Cosine of B equals A is 8, and my hypotenuse is still 12. Again, to get rid of our cosine, we take the inverse. To undo each other, we use inverse operations. And the same idea here with our trig. So, inverse cosine, 8 over 12, when we type that in, it's going to give me 48.2. And we check to see, does that answer make sense? And yeah, it does, because if I were to add up all my angles here, I would get to 180 degrees, which is a good check. So here we have all of our angles. We can use trigonometric ratios to measure distances indirectly, and there's a diagram of this on page 648 if you're interested. The angle of elevation is an angle from the horizontal up to a line of sight. So for example, if you're standing on the ground and looking up at the top of a building, for example, the angle from where you're at on the ground looking up is an angle of elevation. An angle of depression is an angle from the horizontal down to a line of sight. So let's say you're at the top of the building and you're looking down at me standing on the ground. That's an angle of depression. So here, we're going to use angles of elevation or depression to solve a problem. Suppose you're waiting in line for a ride. Here's our ride. There's a better picture of this in the book, but this is our ride. You see your friend at the top of the ride. How far are you from the base of the ride? So here, you're standing here. Your friend is here. And the angle that you're looking up at, so this is an angle of elevation, is 20 degrees. Your friend is looking down at you at an angle of 20 degrees as well. But the angle of depression then is this one. So same idea, just different viewpoint. Now we want to know, how far are you from the base of the ride? So here, we know the ride is 150 feet tall. And we're looking for how far away are we along the base. Like if we were to keep in line and eventually get there, how far away are we? So from my angle, I have two sides, 150 and x. My 150 feet is opposite, and my x is my adjacent. So when we're looking at SO, CA, TOA, O and A is tangent. So tangent of my angle is opposite over adjacent, TOA. To get rid of division, I'm going to multiply both sides. And then to get rid of my multiplication, I can go ahead and divide. Now I can take 150 divided by tangent of 20 degrees. And I get approximately 412 feet. Now you move forward in the line a little bit, and the angle of elevation to the top of the ride becomes 50 degrees. How far are you from the base of the ride now? So we have the ride here. Your friend is here. Or maybe they're off the ride, I don't know. And you're here. And you're looking up here. And this angle is 50 degrees. And you want to know, what is the distance from you to the ride? Well, the ride is still 150 feet tall. So it may not necessarily like have the triangle. There's not like a hypotenuse just sitting there following you along. But you can kind of see the idea here. If you're following it up with your line of vision, and you're looking for how far you're going, we have our triangle here. So from our angle that we know that opposite is 150 and adjacent is x. So if we're talking opposite and adjacent, we're talking tangent, TOA. So tangent of 50 degrees equals opposite over adjacent. And now we solve for our x value. Right now we have division, we don't want it, so we multiply to get rid of our fraction. To get rid of multiplication, we go ahead and divide. And here, I'm going to take 150 divided by tangent of 50 degrees. And now, we're about 126 feet away. So a lot closer. Quick recap here. Sine, cosine, and tangent ratios can be used to find the measurement of sides and angles of right triangles. Angles of elevation and depreciation can be used to solve real-world problems. And that's all I have for section 10.6.